this is increasing and decreasing function. We are taking chapter number 17, class 12, R.D. Sharma solution. Show that fx equals to tan inverse x minus x is a decreasing function on R. So we have taken a lot of questions, and by now you know that f dash x, if it is greater than 0, then the function or the fx is increasing, or when it is less than 0 it is decreasing. So in order to prove that it is decreasing function, we have to prove that it is less than 0. We are differentiating it now. Differentiation of tan inverse x is 1 by 1 plus x square. X is 1 only. Let us take the LCM. If there is any problem, just multiply this one. Take care of the sign. Multiply 1 plus x square with 1. It will be negative then. And multiply the denominators and write it here. 1 plus x square into 1. This is the ninja technique to easily solve. So when it cancels, you will find out minus x square by 1 plus x square. So now we have to show that it is decreasing. This is real number. So every real number, any number which can be painted or put on a number line, those numbers fall into the category of real number. It can be integer, it can be decimal, any number. Let us take the x square first. You are already aware that whenever you have negative or positive, the square will always be positive. So x square will always be positive in any case. When you have x square, if you add a 1 with it, it will always be positive, because adding 1 with a positive number will make it positive only. Alright? See, x square will make things positive, and adding certain thing will always make it positive. So x square is positive, 1 plus x square is positive, whole numerator denominator is positive, but you have a negative outside, so it will always be negative. That is f dash x. Since this becomes negative in any case, it is less than 0, and when f dash x is less than 0, we say, if you remember in the beginning of this question I told you, if it is less than 0, then it is a decreasing function on R. So this decreasing function, let us see how to write it now, because this is logic and writing is most important. So this is how you are going to write. So this portion we have proved it to be positive, and then you have a negative that will make it as negative, that is less than 0. And when it is less than 0, this function is decreasing on the real number R. Now determine whether fx equals to this one, minus x by 2 plus sin x, is increasing or decreasing on minus pi by 3 and pi by 3. So this pi by 3 is what? Pi by 3, those who are not able to understand, I have the duty, I have this responsibility to let them know also, because most of the people might know, but everyone should know. What is this pi by 3? How to convert this radian into degree? Always this will come. So just multiply it by 180 by pi. So now it will be changed to degrees. So 3 6 are 18, so 60 degree. This is 60 degree. We are talking about 60 degree and minus 60 degree. There is nothing called minus 60 degree, but I'll tell you what, it is just a mirror reflection of pi by 3 on the coordinate axis. So we need to find out whether it is increasing or decreasing. First thing what we'll do, we'll just differentiate it. So this f dash x is going to be minus x by 2. This minus 1 by 2 is constant already. So you just have to differentiate x. This is differentiation of x is what? It's going to be 1. Sin x will be cos x. So you have cos x minus 1 by 2. So we'll start with cos x. This is cos x. Now cos x is, this x is between negative pi by 3 and pi by 3. X is in between negative pi by 3 and pi by 3. But if you take cos, let us take the negative part to make you better understand, because plus part will always be the thing which are very default. So now when we take cos on both the sides, cos minus theta is plus cos theta. Cos negative theta is plus cos theta. That is, in sin and tan, sin minus theta is minus sin theta. Tan minus theta is a minus tan theta. But cos negative theta will be positive cos theta. So minus cos pi by 3, this minus will not come here. I am saying it will always be plus. Cos minus theta is plus cos theta. So it will be cos pi by 3, which is going to be half. So cos x is greater than half. When you have cos x which is greater than half, what does that mean? What does that mean? Now this half, where to get this half? Because if it is greater than half, there has to be certain thing. So cos half I am taking on the left hand side. It is cos x minus 1 by 2. I have told you already, f dash x is simply cos x minus 1 by 2. Now it is clear. Now if it is greater than 0, the content or the expression of f dash x, if it is greater than 0, then we say that this is an increasing function. So your question will be, this cos minus theta is plus cos theta. I'm not convinced with that. So there is a second explanation. So this question can be solved in multiple ways. Second part I'm saying, add sugar to coffee we are doing. Now this is pi by 3 and negative pi by 3. What is this pi by 3? 60 degree. And what is minus pi by 3? Whenever you have negative with the same one, it is just the mirror opposite or reflection. So this is negative pi by 3. Now you see, in the first quadrant and in the fourth quadrant, cos x is positive. Alright, and what? It is positive. But we got this pi by 3, so we checked it for pi by 3 and it came cos x was greater than half. So cos x greater than half, then we proved cos minus half is greater than 0, and that is the required and necessary condition for the function to be increasing. Alright, in mathematics there can be multiple ways to solve and explain a particular solution. So it's up to you whichever way you like to answer this question. Now the next thing is to show you exactly what you have to write, because logic is very important. I invest my most of the time in explaining you rather than writing it. That is logic is important. Writing you can do if you know the logic. See, if you have knowledge, you can get the job, right? So it's better to have logic. Job you will get. If I tell you the logic, you will write or you will solve the question by yourself, right? So this is the logic which you have to follow. All these mathematical symbols for all this you have to write. Find the intervals in which this fx equals to log 1 plus x minus x by 1 plus x is increasing or decreasing. So this is an important question. Why it is important? Because it has already come in CBSE. It has already come in the examination. In order to take these kind of questions, we need to have multiple mathematic topics in our mind. That is, you need to know log, you need to know differentiation of log. So this is log 1 plus x. What will happen if I put x as minus 1, log 1 minus 1 is 0. How can you define it? So you cannot have x as negative 1. 1 plus x cannot be 0. 1 plus x equal to 0 is the problem. X equals to minus 1 is the problem. So x cannot be minus 1. How about x by x, 1 plus x? 1 plus x cannot be 0. 1 plus x cannot be 0. That means x cannot be 0 because you are adding 1 to x only. 1 plus x is equal to infinity means what? X equals to infinity minus 1. If you subtract anything from infinity, it will be infinity only. If you add anything to infinity, it will be infinity only. So you have log 1 plus x, it is saying negative 1. X by 1 plus x is saying it has to be between negative 1 to infinity. That is, I am telling the domain. The domain is very important. So this particular function is valid only between negative 1 and infinite. Alright, I hope you got the idea. So this 1 plus x cannot be equal to 0, x cannot be equal to minus 1. 1 plus x cannot be 0 in log terms, so it cannot be equal to minus 1. So it has to be higher than minus 1. Higher than minus 1 means minus 1 to infinite. Now I am differentiating. Log 1 plus x differentiation is 1 by 1 plus x. X by 1 plus x differentiation is what? So we'll do it using the equation rule. 1 plus x square here. 1 plus x will be here. A differentiation of x will be 1. Then you take this minus. So this x is there. Differentiation of 1 plus x will be 1 only. So in the numerator you have 1 plus x minus x get cancelled. You have 1 by 1 plus x whole square. So you have 1 by 1 plus x whole square. Next thing you can do is to take the LCM and you can solve it. And this is how you can go about it. But I always have a better idea for you. So better, rather than going for this cumbersome method, we know that 1 by 1 plus x is common. Why not to take 1 by 1 plus x common? So if you take 1 by 1 plus x common, you will get inside what? 1 minus 1 by 1 plus x square. So 1 plus x square was there, so 1 plus x already taken, only 1 plus x is there. So now cross multiply. 1 plus x minus 1 by 1 plus x. So what do you get? X by 1 plus x. So solving this by my method, it will easily make you feel easy to solve it. So x by 1 plus x square is there. Now you just see, if you want to show it increasing, it has to be greater than 0. If you want to show it decreasing, it has to be less than 0. This is very much in your mind. But please remember, the domain is only from negative 1 to infinity. X cannot be negative 1. It is always higher than negative 1. So we went up to infinite. That is, minus 1 to infinity was the domain. So this 1 plus x whole square will always be positive. So that means x should be greater than 0. That is, I am saying in between minus 1 and infinity, f dash x is greater than 0 when x is greater than 0. But we have the domain minus 1 to infinity. We have x greater than 0 now. So you cannot take this point. It is greater than 0. So you will take only things which are beyond 0 up till infinity. So this will give you 0 to infinite. This will not be taken. This cannot be taken. 0 to infinite is what f dash x greater than 0 gives you. So f dash x greater than 0, that means you are talking about 0 to infinite. This is the answer. Alright. But what about the less than 1? Decreasing. We have to tell the interval also of less than. Now we have come to the decreasing one. So f dash x should be less than 0. So x plus 1 by x whole square should be less than 0. Now this 1 plus x whole square, that is anything with square, cannot be 0. See, even power will always give you positive sign. So that is only giving this as x less than 0. The numerator has to be 0. Then only this whole will be 0. Now x less than 0 means what? I told you the domain was -1 to infinity. Because 1 plus x cannot be invalid value. X by 1 plus x in 1 plus x cannot be invalid value. So it is saying x less than 0. So you can, the domain is -1 to 0. This is the wall. You have to go below 0. So you can just go up to -1. So -1 to 0. This is what is the interval in which it is decreasing. X should belong to -1 to 0 in order to be the function decreasing. From 0 to infinite, I told you that it is actually increasing. Now how you are going to write it? So we have to write it like this. All these mathematical content, writing, the sentences, different symbols have to be used in order to solve this. But before that, domain is important here. This question is totally based on the domain. If you don't know -1 to infinity, that will be a problem. So this is also an important question. Why? See, in this CBSE, it has already come in 2000. So those questions which have come are going to repeat. Now some students will do NCERT. They'll say, I've done everything, but my marks has not come. The question is not from NCERT. That is where the R.D. Sharma and R.S. Agarwal comes. In these books, there are multiple questions, same question with multiple twists and turns. So if you do NCERT first and then you can complete R.D. Sharma or R.S. Agarwal, I'm sure that you will get complete full marks. That is my guarantee. That is, if you do one thing again and again, you are going to get practiced. And once you are perfect in your practice, you will learn that thing that will be in your subconscious mind. When the question will come in your examination, you will be able to solve it easily. So x plus 2 e raised minus x is increasing or decreasing. We have to tell the intervals. So let us go to the intervals. First thing first is differentiation. We have f dash x. So this differentiation x plus 2 and can be taken as one term. E raised minus x can be taken as another term. So I have differentiated e to the minus x first. Then I'll differentiate x plus 2 in the second one. That is x plus 2 differentiation is 1 only. So what do you get? Just multiply inside. So you are getting this one. Now e raised x minus 2 e raised minus x will be minus e raised minus x. That means this, if you take the last two terms, 1 minus 2 is going to be negative. So it will be minus x e raised minus x minus e raised minus x. What you can do is, you can take e raised minus x common. Minus x minus 1 will be inside. So if it is increasing, f dash x should be greater than 0. Differentiation should be greater than 0. That is e raised minus x minus 1 should be greater than 0. And the second part, see, on Eve, anything power is there, it will always be positive. How? Because e is a constant value. It is 2.174 something. So if you put minus 1 on as the say power or plus 1 as the power, both of the time you are going to get only same positive number. So e raised minus x or whatever happens, it will always be a positive value. It will be always greater than 0. How about minus x minus 1? If you take minus common, this is x plus 1, which is greater than 0. My idea is to multiply both sides by -1. So when you multiply negative on both sides, the inequality sign will change. This greater than will be changed to less than. So now you have x plus 1 less than 0. That is, x should be less than minus 1. X should be less than minus 1. So anything which is less than minus 1, it goes from -1 till minus infinity. So you can just say that x less than minus 1 means we go till minus infinity. So minus infinity to minus 1 is what we got from here. Now the next thing is decrement. That is when the function is decreased. F dash x should be less than 0. What does it mean? E raised minus x minus 1 should be less than 0. When it is less than 0, e raised minus x, as we just discussed, that it will always be positive, whatever be the case. It will always be positive. That is, minus x minus 1 should be less than 0. If you take minus x minus 1 should be less than 0, minus you can take common, x plus 1 less than 0. Now you multiply both sides by -1. When you multiply both sides by -1, what are you going to get? The inequality sign will change. It should be greater than 0. So x plus 1 should be greater than 0. That is, x should be greater than -1. Now when you start with the -1, anything beyond -1 goes up to what? It goes up to infinite. So -1 to infinite is the point or is the interval where this function is going to decrease. So this -1 to infinity I am going to write for the decrement, and negative infinity to -1 I will be writing it for increment. So this -1 to infinite I am writing it here. These are the two intervals on which this function is going to increase or decrease. Important question this is. It is going to come in the examination, please understand that. Now what will be the solution? How are you going to write? formally. So this is the formal solution which you see here. This is the increasing result, this is the decreasing result, and this is how it has come. Now show that the function f given by fx equals to 10 raised x is increasing for all x. Now this 10 raised x is a very straightforward question, because if you know the differentiation of 10 raised x, that I'm sure you are already knowing it. So a raised x differentiation will be a raised x log a is 10 here. So I'm saying a is 10, so it will be 10 raised x log 10. Now anything on the 10, negative or positive, it will always give you positive. 10 raised minus 1, 10 raised positive, and just check it out. In both the ways, you'll see that it is going to be positive. So it is always greater than 0. How about log 10? This is already a constant number. It cannot be negative. It's a positive number. So log 10 is greater than 0. So when plus into plus is there, it is positive. So this is greater than 0. It will always increase. So this is how you are going to write it. There are only few lines you have to write. The logic, if it is clear to you, it will be, you can write more of the lines. You can just say a raised x differentiation, show it to the examiner, and then you write all these lines. Prove that the function fx x minus this is greatest integer function is increasing in 0 to 1. Now they have made the solution quite easier. This is greatest integer function. This is not modulus, okay? These are square brackets. So if you put any value, if you place any value between 0 and 1, that is just below 1, 0.99999 like that, the greatest integer function will always give you the lower integer. It will always give you 0. So I'm just saying that you have 0, 1, 2. Any value below 1 will always give you 0, greatest integer function. Any value between 1 and 2, which is just lower than 2, not equal to 2, will always give you 1. That is, if you put 1.99, it will give you 1. So integral value will come. So I'm just saying that the interval is already given 0 to 1. So just take two numbers, say x1 and x2. I'm saying x1 and x2 are some random numbers we have taken in this interval, 0 to 1. And this x1 and x2 should be between 0 and 1. It should belong to 0 and 1. So x1 is less than x2. That is, x1 is 0, x1 is 1. But 0 and 1, as I'm saying that I'm not taking integers now. I'll take some value which is just lower than 1. It will give you same number. I'm just saying that the greatest integer function is only helpful when you have non-integral value. That is, the integral value, the greatest integer function will always return the same number. Greatest integer of 0 will be 0, greatest integer of 1 will be 1, but we are talking about anything which is between 0 and 1. So I am saying the greatest integer value function of x1 will be x2. Why? Because we are in interval 0 and 1. So between 0 and 1, you can give any value which is not equal to 1. That will always give you 0. So x1 is less than x2. We started with x1 less than x2, and I told you the greatest integer function will give you either 0 or 1 if you put a certain value, but it will always give you 0 in this 0 to 1 range if it is not equal to 1. So I'm subtracting these equal, because x1 and x2 are equal. You will just argue, that x1 and x2, they are different. How can you subtract the same different number from the same number in the inequality? So I'm just saying that if you take the greatest integer of 0.5, it will give you 0. 0.9 will give you 0. So that is why this greatest integer function of x1 and x2, which are between 0 and 1, will always be 0. So if you take 9 and 10, I take the greatest integer function of 9.1 and 9.9. It will always give you 9. That is why this greatest integer function is, they are not different. They are actually equal. So you can equal a equal number from x1 and x2. That is the logic. I hope you got the idea. So this x1 and x2 are the same value. So I hope that whole discussion is clear to you. So x1 minus greatest integer function of x1 is what? It is fx1. The other one is fx2. So when you started with x1 is less than x2, you found that fx1 is less than fx2. So that means this function is increasing in 0 to 1. So this is the logic. Differentiation of greatest integer function will take a lot of effort. It has different signs. So this is the whole idea. I explained you with numbers. If you're able to explain with the numbers, that is also beneficial. But if you have time only in your exam, then only do that. Otherwise, this kind of solution is more than enough, and the logic of differentiation won't work here. X minus greatest integer function differentiation is beyond the scope, right? This question we are going to take in the next discussion. Till then, thank you so much and take care of yourself.